Hi, welcome to the Virtual JBug. Today we have John Frizelle, who is a software architect at Red Hat. John's going to talk about the Red Hat mobile product which he works on. He's going to give us a demo of how you as a developer can get started using Red Hat Mobile today on OpenShift. Before we start, I'll apologise, we've been having some problems with the technology, so we can't get the feed from his laptop to stream, so hopefully the camcorder will be good enough for watching what's happening. Okay, so I'll hand over to John.
Okay.
Thank you. We're just hooking John's mic up. We forgot to set that up while we were having problems with the laptop. We didn't think about this.
Okay, are we audioed up?
Yeah, do you want to just stand up so we can see you?
Yep, okay.
Yeah, it looks like we can hear you okay.
Alrighty. Okay, so welcome everyone, both local and remote. My name is John Frizelle. I'm the Chief Architect with Red Hat Mobile, formerly with Feed Henry, which was a acquisition by Red Hat in October 2014. Feed Henry started out as a research and development project, basically in an R&D centre in Waterford, Ireland. We got angel investment, Series A, VC funding, and then acquisition October 14. Post-acquisition, we've been rebranded from Feed Henry to Red Hat Mobile Application Platform, and are now working in the larger Red Hat family, building out that product and starting to open source it. You can find me on Twitter at John Frizelle and on GitHub, John Frizelle as well. Okay, I don't have too many slides. I'm not a big fan of slides. Most of this is live demo, a little bit of coding, and all kinds of things going wrong. But a couple of slides just to set some context. So the Red Hat mobile platform is comprised of two core parts. Did you say you had a pointer?
I did have a pointer, yeah. It's probably better if you stand on the other side if you don't mind.
Yep. That's not a pointer.
It is. It's wireless. No, sorry, you need to plug that into your laptop.
Oh, I don't have any USB ports.
Oh, right.
It's grand, that's grand. Okay, so yeah, the platform is basically divided into two main components. We have what we call the core platform and the MBaaS. So core platform is where developers, line of business users, people who are using the platform come to create mobility solutions, to look at analytics, to view logs, to debug, that kind of thing. Download SDKs, templates, development tooling. The MBaaS then, when you're writing a mobility solution on the platform, we don't talk in terms of an app, because the app is just a front-facing bit, the bit in your hand. There's typically a lot more behind it to make up a full mobility solution. So the app has to communicate with something to get data. And with our platform architecture, the app on device will communicate with a Node.js-based API server that we host for you in the MBaaS. So when the app starts up, it will start communicating with an API server that the developer has created here, and from there, it can connect into backend systems. Out of the box, you get things like caching, storage, data synchronization for offline usage, API management, push notifications, and various other APIs. Similarly, on the client side, you have SDKs that give you the same kinds of things, the storage, data synchronization, calls, easy access to call into the app in the MBaaS. So typically, our users will use the core platform, and the users of the apps that are developed will use the app that then communicates with this MBaaS. So this is the bit that we're going to be running on OpenShift today. And this is hosted by the Red Hat Mobile Operations team in Amazon. Okay, so some key concepts. MBaaS, as I already said, Mobile Backend as a service, the thing that hosts the Node.js apps that serve the mobile applications. An MBaaS service it's not the API bit that the mobile calls, it sits behind that and gets called by the API server. So basically, if you're building out functionality, say to connect into Salesforce or a CRM system or whatever, you don't want to redo that connectivity every time you build an app. You build it as a service, build it once, and then associate it with as many apps or projects as you want. So the demo we're going to be looking at today, we have 3 services that we will be hooking in. Then we talk in terms of a project. As I said, rather than an app, we talk about a project. So the project has the client apps, so the mobile application on your device or web portals, the cloud app, which is the Node.js API server, and these MBaaS services. They're basically Node.js microservices. So the demo app we're going to be looking at is an app that allows you to scan barcodes and get data. Very simple app, but it illustrates many of the key points. So it uses an external service called SearchUPC for barcode lookup. SearchUPC exposes some of its APIs via SOAP, including the one to do a search for barcode. So we'll invoke a SOAP endpoint. We'll get an XML response back. Buried in that will be a CSV with the details of the barcode. We convert that to JSON and return to the client. SearchUPC also has, if you go to their homepage, and we'll look at this in a minute, has a list of recent searches, the 5 most recent searches that people have performed. But that data is not available via their API. So to get that, we're actually we're doing a GET request on the SearchUPC page, loading it into an in-memory DOM parser on the server side, and screen scraping basically to extract that data. But again, we're encapsulating that behind a nice API, so the app on device has no idea that we're doing this dirty, nasty hacking on the back end. And we have a very simple mock order service to simulate being able to search for a barcode and then say, I want to order one of them. So this is kind of how it looks. You have your app on device, talks to a set of APIs exposed by this guy. He in turn uses these 3 microservices. So this one to communicate with SearchUPC. This one, because when we get the response back from SearchUPC, it includes a URL to an image of the product you've searched for. Typically, they're URLs to somewhere on Amazon because, well, Amazon sells everything. So we have a little microservice here that's reaching out, pulling back an image stream, optionally base64 encoding it, and sending it back. And then we have this little sample order service, exposes a set of APIs for add an order, update quantity, delete an order. It's just an in-memory thing, but the idea here is that if we did actually implement connectivity into a back-end order system, so long as we maintain the APIs that are exposed here, we could actually swap this out and swap in a real order system. So there's nice encapsulation, kind of separation of concerns. In terms of within the product, how that maps is to this. So again, we can see the client app, we can see the Node.js API server, and we can see the 3 microservices that we're going to use. Okay, that's it for the slides. So let us do some coding. Okay, so to start with, if you go to openshift.feedhenry.com, you'll hit this landing page here, and it gives you an option to request an invite. So basically, go in here, fill in your details, ideally using the same email address that you use for OpenShift Online. If you don't already have an OpenShift Online account, go to OpenShift Online, you can get one for free. So once you've signed up, you'll receive a one-time invite link. Click on that, and you will then be able to log in using your OpenShift credentials. So as I said, it's important to have the OpenShift account because we actually proxy the identity check to OpenShift. So it's your OpenShift credentials you're using to log in. So as part of logging in, not only do we proxy the authentication request to OpenShift, Um, but we also use the username and password that you enter in one time to generate an OAuth token and a public-private key pair, so that the account that you create here is able to communicate with OpenShift on your behalf, to deploy apps, to create apps, that kind of thing. So within our console, we can see in the admin area that we have this thing called an MBaaS target, and we can see that there's one set up here for OpenShift. This gets automatically created the first time you log in, along with 2 environments. So the environments here are for lifecycle management. We tend to limit it to 2 because with a free OpenShift account, you only get 3 gears, so you'll run out of space pretty quickly. You optionally can create additional environments, but in this kind of usage scenario, there's not a huge amount of benefit to it. Within OpenShift itself then, in the settings area, we can see, I've recreated a couple of times here, which is why there's so many keys, but we can see the keys that have been automatically created, and we can see the OAuth session that's been created as well. So if we were to remove them, the system over here would prompt you for your username and password again. The next time I try to talk to OpenShift, regenerate the tokens, and then communicate with OpenShift again. Okay, so this is the screen you land on when you log in. I'm just going to take a quick run around the functionality on the screen. Getting started, as the name suggests, videos, tutorials, samples, welcome guides, that kind of thing. Projects is where we're going to spend most of our time, but I'm going to cover the others and come back to it. This is basically where you lay out your mobile projects with your client apps and your cloud apps. Reporting and analytics gives you details about installs, startups, things like that. I don't think I have very much data because this app hasn't been used very much, but okay, we can see that there's been 2 startups. This is where you go to create those Node.js microservices we were talking about. So we can see that we have the 3 services we created here. When you go to create a new service, there is a suite of templates that you can start from. So you get some boilerplate code out of the box for connectivity into different backend systems. This just links directly to the API documentation for the MBaaS and for the client APIs. So again, we have full access to the full set of API documentation. Drag and drop apps it's designed more as a kind of a line of business thing. It's for non-technical users to be able to come in and create forms for data capturing. That with a click of a button, they can generate a mobile app and start automating some kind of manual paper-based processes that might exist at the moment. There's functionality in there to be able to connect into back-end systems to pull data out of them and push submissions back into them. You're typically coming out of the realm of a line of business user. At that point, you need a developer to do that initial setup, but then the line of business users can create forms and build applications without writing any code. The admin section we've already been in. So we talked about environments and MBaaS targets. There is also functionality for a very lightweight mobile app store that you can upload either applications that are created here or other applications you have, and then expose it via this URL here. End users can log in, download and install applications. Okay, so that's at a very high level the main functionality. So let's go and take a look at projects. So similar to the services, when you come into this screen, you have the option to create a new project. Again, there is a suite of different templates, native iOS apps, native Android apps, Cordova applications, and various other samples, Windows Phone, App Accelerator, Xamarin, and so on and so forth. or you can start with a completely bare project and build it out yourself. So the one we are going to be looking at is this barcode project. And we will already have seen a screenshot of this in the slide deck. So we can see again, the client application, the Node.js API server, and the 3 microservices. So let us take a look at the client app first. Okay, so when you come into the client application, if it is a Cordova application, meaning that the development is done using HTML, CSS, and JavaScript predominantly for the UI layer, you'll get a live preview here of the application, and a set of details about it: name, description, its internal ID, API key that it'll use to identify itself, and the get SSH URL for cloning the source code. There is an area for documentations. It basically just renders the readme.md from the root of the Git repo that is automatically created when you create an app. This is handy for people to just share information about the project. So if you have a team of developers on it, things like setup, getting started, testing, CI/CD, all the stuff you'd expect to see in a README. It's just to make it a little bit more prominent for new people coming onto a project. There is an online editor, which other than for like really simple typos or quick updates, you're unlikely to use. But it does give you the ability to at least take a look at the code of it and make small quick changes. So we can see here that it's a very simple HTML application. Little bit of JavaScript for communicating with the server side. We can see, for example, actually, I'm not going to look at code too much here because we're going to look at it in Atom, and I can bump up the font a lot easier there. Again, we have per app analytics. The reporting and analytics we looked at a minute ago was global across all projects. This gives you analytics specific to just this particular application. Various configuration options. Again, this is a kind of a wrapper just around the Cordova config files for people who aren't familiar with mobile and may not know the different configs that can or should be set. The main ones are surfaced here to make it easier for people to quickly tweak settings about the application. Integration for push notification. So this is actually an integration with the AeroGear unified push server project, which is also a kind of a Red Hat driven open source project. Okay, so we then have the build option. So what this allows you to do is take the source code that we saw in the editor, choose your platform. In this open registration version, we currently only have Android support. We're looking at potentially adding iOS support at some point in the next couple of months. Android, iOS, and Windows are available in the full commercial offering. But as I said, at the moment, it's just Android here. So you select your preferred platform, what branch or tag you want to build from. We're just building from master. Your build type, debug, or release. And then what cloud app, Node.js API server do you want to hook it up to? We only have one here, so there's not much of a choice to make. So you configure those settings and then you click build. So basically what it's doing is it's taking all the source code, zipping it up, sending it to what we call our build farm, which is a set of hosted VMs, Linux, iOS, and Windows. Sorry, Windows, OS X, and Linux. Sends a zip file across, the credentials, any other required information. The standard build tools, be it Xcode or Android build tools, are invoked, and a generated application is returned that you can download, install on the device. It will provide a QR code so you can scan it for a quick installation on a device. And then it makes the build available in the history section here that you can come back and download previous versions at a later date. Okay, so our build is completed. As I said, it generates a QR code. It gives you a short link that you can just pop into a browser to download it, or it gives you the option to download the actual artifact directly. And as I said, that in this case with Android, that would be an APK file that it would download. Export, similar idea. It takes your source code, sends it to the build farm. In this case, because it's a Cordova application, it wraps the Cordova layer around it and sends it back. So if you wanted to do local development with Cordova, you could export and you'd get the Cordova wrapping. Credentials are basically for managing credential bundles. So in particular with iOS, you need 3 pieces of information to do a build. You need a certificate, a provisioning profile, and a private key. With Android, to do a debug build, you need nothing. To do a release build, you need a private key and a certificate. And the reason that the credential management is here is we've seen time and again, particularly with Android, developers can generate these keys themselves, which makes them feel fairly transient and not necessarily particularly valuable. Like with iOS, you have to go to the developer portal and go through a big rigmarole to download the files you want. With Android, you can generate the private key and the certificate locally. You build your application, and then as a typical developer, you forget where they are, or you delete them, or you reformat your computer, or whatever, and they're gone. You can never update that app in the Play Store again without the private key. So by making storage for the credential bundles available on the platform, you have somewhere safe and secure to host them right beside your source code, right beside your generated builds. So be it 6 days, 6 weeks, or 6 months later when you come back, you know exactly where your credentials are, and anyone else who's working on the project knows where they are and can come back and do additional builds. Okay, so let's have a little play around. Oh, that's a little bit too big. Okay. So as I said, the app is a very basic Cordova HTML application. It's as ugly as can be, but that doesn't matter. So as I said, it gives you a list of the recent searches that other people have done. So let's quickly just go to searchupc.com. So this is a Search UPC website. You can see the same list of 5 recent searches here. And click on them and it'll give you the details of what someone else has searched for. So in this case, kitchen faucet. Similarly, back here, we can click on a barcode. Okay, in that case, the barcode that someone searched for didn't have any product associated with. Let's try another one. Mobile phone repairing course. Okay, I've had some interesting experiences doing this demo previously with some of the really, really weird and random things that people have searched for. Not all barcodes are suitable for work or suitable for presentation. So, disclaimer, I don't control what shows up here. Big Bang Theory, cool. Okay, so that's our basic application. We'll start looking through the source code of that in a couple of minutes. Before we do that, what I want to do is, go back to this screen here. We've now looked basically at the innards of this. I want to move over and look at this one next. Okay, similar idea, you land, you get a details page. In this case, because it's something that we're hosting and running for you, you get information on the current deployment status. You can stop, you can start, you can restart the application. It tells you where it's deployed to. So in this case, it's OpenShift Online. If you had, for example, an OpenShift Enterprise installation yourself, currently OpenShift 2, we're working on OpenShift 3. you will be able to hook that up as well. It doesn't have to be OpenShift Online. It gives you a link to the URL of where the app is currently hosted, and SSH details for SSHing directly into your OpenShift gear. Details on what has been deployed, what branch, what commit, and again, app ID, API key, and SSH clone URL, same as we saw for the other one. Similarly with docs, it's a rendering of the readme.md file, except in this case what we've done is we've layered on support for API Blueprint on top. So API Blueprint, if people are familiar with it, is a specification for how to write API documentation just using Markdown. So if we were to look at the README very quickly, API Blueprint is able to understand this based on headings and kind of the different formatting. And we're then able to take that, render the API documentation in an interactive way, and you can actually try it live and it will make the call. And fingers crossed, we should get back a list of 5 barcodes. So that has actually invoked the code in the Node.js app, which in turn invoked the service, which in turn went to search UPC and gave us back our data. Okay, editor, same idea. Environment variables, pretty self-explanatory. You can configure environment variables and deploy them. So for example, connection string for the database, it's going to be different in your dev environment from your production environment. So you add a variable, db con. Give it a value for name. It's not blank. Oh, underscore, sorry. So we can see now we're in our development environment and we've given it a value of foo. We can switch to our production environment. The environment variable is there, but it doesn't yet have a value. So basically, environment variables. Data browser allows you to visualize the data that has been stored in the MBaaS. It's not working, moving quickly on. I don't know why that is. Basically, it gives you a tabular view of the various collections that you have created in Mongo. Allows you to view the data, edit the data, export it, that kind of thing. Deploy screen. Oh, it was because I had switched to the production environment. And the app isn't deployed in the production environment, hence the data browser didn't work. So if we go back here, so we can see that there's one collection with one record in it. Okay, deploy then, this is where you come when you've built your Node.js application and you're ready to deploy it, in this case to OpenShift. Again, you choose your branch or tag and you hit deploy. And basically...
So John, please,
yes.
it's actually a quick question.
Yes.
So so having this data store in the MBaaS, does that mean that basically I could write an app that could run on both an iPad and an iPhone, for example, and then as a user, I can have my state synchronized between the two without the developer having to set up infrastructure and so on?
Absolutely correct, yeah.
Excellent.
So the combination of a hosted Mongo instance plus the data synchronization APIs that we make available on the client and cloud allow you to very quickly and easily store and load data from the device. And in particular with the data synchronization APIs, it's designed primarily to allow you to build applications that will work in an offline mode. So very, very frequently, we find scenarios where customers, like there's a rail company we work with here in the UK, and they have people doing inspections of tunnels. So they're a half a mile into a tunnel. They're not going to get any signal, but they need to be using the various applications. So the data synchronization framework ensures that the app continues to act and behave exactly as it would if it were online. It'll store everything locally, and then when it gets connectivity, it starts a two-way synchronization to push up the data it has and pull down any changes from the cloud. Okay, so sorry, back to deploy. So yeah, again, we can see a of previous deploys. We can hit deploy. I'm not going to do it because it typically takes anything from about 3 to 10 minutes. Typically about 10 minutes the first time because of the overhead on the OpenShift side of creating, I think there's 4 cartridges within the gear that are created. We can actually see that over here. So we can see, so when you go to do a deploy for the first time, it needs to create a cartridge for Node.js to host your source code. It creates a cartridge for Mongo for data storage, cartridge for Redis for caching, and a cartridge for kind of back channel communication between the application and our mobile platform. So that's for things like sending the analytics data, notifications or alerts, that kind of thing. So this guy will sit in the background and feed data back to the core platform. Okay. We then have stats. Pretty sure there's a slight glitch in this at the moment that it's not showing up the endpoint stats, but basically it would show you graphs and trends of requests, request duration, 98 percentiles, things like that. So it's a very kind of quick heads up of how your application is performing. Is it under high load? Is it suffering from long response times? That kind of thing. Notifications are basically an audit log of things that have happened with the application. So when was it deployed, who did the deploy, stopped, restarted, crashed, that kind of thing. So it gives you history on what's happened to the application. From there, you can create alerts, which basically, so say we wanted a crashed alert, event category is app state, event severity is fatal, and the event name is terminated. And so now anytime a notification is received that matches that alert filter, it will generate an email and it will record it in here as a notification that has been sent out. Logs, as the name suggests, gives you access to the log files from the application. So we can see here, we've been using the application a little bit in the studio a few minutes ago. So we can see basically the various information. Sorry. So for example, the barcode read endpoint was called, that was the barcode ID. We hadn't cached it, so we called the barcode service. This was the Big Bang Theory one, and the various data for it. Okay, so that's the main kind of details of the client and the cloud. The MBaaS services are actually remarkably similar to the cloud app. They're Node.js applications. You have your data browser, you have your alerts, you have your yada, yada, yada. They're conceptually different in that they can be reused across multiple projects, but under the covers, it's a Node.js application in the same way as this one is. Okay, very briefly then, let's take a look at lifecycle. So this basically gives you a heads up of what version of what is deployed where. So we can see that we have 6 builds done of the application. We can see when the last build was. We can see what type it was, that kind of thing. We can choose to promote this build to production, which means that the next time the application starts up, instead of calling the dev Node.js application, it will call the production one. And similarly, we can see the Node.js application here, status and details on what was deployed, how many clients are using this, and which MBaaS it's been deployed to. So that 6 there corresponds to the fact that we've done 6 builds. So we have 6 instances of Android apps floating around that are using this server side. They are represented as connections. So each time you do a build, it generates a new connection tag to do the mapping between the binary and the cloud application. So from in here, you can go and you can configure the connection and actually repoint an application from one API server to another one, even after the application has been built and deployed. So it gives you quite a lot of control over managing applications on device. You can also disable a connection. So the next time the application starts up, when it calls back to the platform to say, where's my Node.js API server, it will get a response back saying, you don't get one, you've been disabled. And typically then the developer listens for that message and renders an alert to the user. Okay. Let's take a look at some code. Before I do, is there any questions at this point?
Yeah, so as a developer, I understand I can get like 3 gears on OpenShift without having to pay any money.
Correct.
At what point, so then I can use Red Hat's mobile platform as well with those gears.
Yes.
And then, so at what point do I then have to start paying for this product? So as a developer, how much can I use before I need to start spending money?
Good question. So to get this sample up and running, you would actually need to pass that threshold, because we have here 4 Node.js applications that are deployed into OpenShift, and we can see them. We can see them here. So I have upgraded my account to 16 gears. By default, you get 3 gears when you start. So I really should redo this demo and probably take out the order so that it can be run on a free OpenShift instance. But basically, you'd be at your capacity at that point in terms of the number of OpenShift gears. If you wanted to continue to experiment without going onto a paid plan, probably the easiest thing to do would be to download OpenShift Origin, run it yourself, and then hook up to that, and you have as many gears as you want in the self-installed, self-owned OpenShift.
Okay, yeah, makes sense.
Alrighty, so let's look at some code. Okay, so I've cloned the various repos previously. So we have the client app, we have the cloud app, and we have the 3 microservices. So we've already taken a little look at the client application at the index.html file and some of the JavaScript files. So as I said, pretty basic HTML file. In the JavaScript file here, for example, again, this was fairly deliberately done without using too many frameworks, without even using jQuery, just to keep it as simple as possible and not kind of confuse the message. Now, that has resulted in it looking particularly ugly, and God knows I'm not a UX person, but I think there would be benefit to going back and prettying this up a little bit. Okay, so we can see here, the $FH is our hook into our SDK, and we're calling the cloud function on it, which basically means figure out where your Node.js API server is and call that endpoint. So as a developer, you don't have to worry about the connection tags and the URLs and the resolving. All that is taken care of by the SDK. And you can just call the cloud function, pass it the path you want to call, and the data you want. If you want to do a standard REST call yourself, there is a get API server URL function, I think it is, in here as well. So you can use that to tell you the host name and then do standard AJAX requests if you want. So yeah, this is us calling our barcode read endpoint, getting our data back, and literally just updating the DOM to display the information. So if we look at the cloud app, so again, here is us pulling in our server-side APIs. And this is a standard for those that are familiar with Node.js and with the Express web framework. This is a standard Express application. So set up our application, enable cores, some boilerplate APIs that the system itself uses, and then we mount the APIs that we want to serve. So in this case, we have a barcode API and an order API, and they're implemented in the corresponding files. So if we look at the barcode one, for example, so we can see that under /barcode, it mounts a recent endpoint and it mounts the read endpoint. So if we look at the implementation for the recent one, just to get some kind of idea of what we're doing here. So we have aliased our server-side SDK here to nice short variable fh, and we're using the cache functionality, which, as we saw over here, is backed by Redis, to check to see if we have already done a recent search, if we've recently gone out to search UPC, done the screen scraping and got the 5 recent searches back. If it's in the cache, return it immediately. If it's not, call out to the microservice and on to search UPC. This is us calling out to the service, to its endpoint, and when we get the response back, stick it into the cache for 10 seconds. So it is a very, very standard pattern that you would put in that kind of Node.js API layer. You're basically putting caching as edge, as close to the edge as possible. And if you have a cache miss, go to your service, do the lookup, put it back in cache. Similarly, for the read endpoint, we check to see if we have anything in cache for it. If not, we call the barcode service and say, can you do a read on the barcode ID? When we get our response back, first thing we do is we trim the payload. So there's several pieces of information in the response from search UPC that we don't care about. So we get the response back and we start taking the objects that we're not interested in out, and putting in some things that we are interested in. So for example, we take out the image URL, and down here, we replace it with a call to the image service and get back a base64 encoded version of the image. And what that means is we can send the entire response back to the device, including the image, in just one HTTP request. We've stripped out all the crap we don't care about. So the payload that's coming back is exactly what the mobile application needs, no more, no less. And that's quite an important thing to think about, because mobile is quite a different paradigm to kind of typical web development, where you're most often you're going to be on a good network, probably wired or a good wireless network, good strong CPU. It doesn't really matter if you get extra information back in a request, or if you're doing 2 or 3 or 10 requests to load a page, because your connectivity is typically pretty good. Whereas one of these out in the middle of a field, or just at the mouth of a tunnel on a crappy, lossy edge network, every byte matters and every request matters. So building out that API to serve exactly what the application needs and only what the application needs is a really, really important thing to do. And that's why every time you create a new mobile project in the platform, you create the piece that lives on the device, and you create the API server to service the app that lives on here. That's the only reason it exists. If you were to delete the app, you delete the corresponding Node.js API server. Okay, so let's follow this through. So we saw that when the recent endpoint was called, we in turn, if we didn't have a cache yet, we called our barcode service and called its recent endpoint. So if we go down here, have a look at the barcode. Again, standard application JS looks very, very similar. In this case, we're only mounting one route because this service only deals with interacting with Search UPC. So in here then, again, we're setting up a route. We're storing the access token for Search UPC. It can be passed in an environment variable, or in this case, I've just hard-coded in the one that I have. So yeah, again, set up your express route, register your handler. So when the recent endpoint gets called, we make a HTTP request to Search UPC, a GET request, and we get a response back. We use a little Node.js module called JS-DOM to load the HTML response we get back. Basically, it creates a virtual DOM that you can then manipulate to interact with the contents of the web page. As we load in the body, we inject jQuery as well. So it'll load jQuery from jQuery.com into the HTML response we got back from Search UPC. And then that allows us to use all of the jQuery goodness, like selectors and iterators, to get to the content we want. So we can see here that our selector is saying that somewhere there's an ID called current searches that has a list of children that are links. And for each of them, we just want to take the inner HTML. So on the Search UPC website, we can see there's our span with the ID current searches. So that's what we're coming to, and then iterating over each of the A elements and just taking the inner HTML out of it. We pop them into a JSON array and then return the array. So you can see there in 16 to 41, and about 25 lines of code. We've pulled in a HTML page, loaded it into a DOM, injected jQuery, and scraped out what we want and returned it as a nice clean JSON object. So if Search UPC, for example, changed, it was now just called recent, we can come in here, we can change our code, redeploy that service, and it's completely transparent to everyone else. We'd make the change in here. It's completely transparent to this guy and this guy. So you have nice, clean separation of concerns between the functionality. Okay, so similarly then for the read one, in this case there is an API available. So we load up the WSDL that's provided, create a SOAP client. Again, we're using a little Node.js module here to do that. Sidebar actually. Just for people who may not be available, sorry, for people who may not be aware. NPM is the Node Package Manager. So this is where one comes to find available packages. There is a ridiculous amount of 257,000 packages on NPM and growing quite rapidly. So for example, if I did search for SOAP, so I'm pretty sure it's actually that one we're using, but 293 results. You can see how many stars it has. That gives you kind of a relative indication of how popular, how used a particular module is. Click into it, it'll give you links to the GitHub URL and stats on how many downloads it's had today, last week, last month. Again, that's a very good indication of how reliable or popular a particular package might be. That is one problem that you find with Node.js. The NPM ecosystem, while it's very, very active, it's almost too active, hence the 250,000 packages. So finding quality packages is not always that easy to do. Yeah, so anyway, we create our client. We call the get product endpoint, give it the barcode we want, give it our access token. We get a result back. In there is the product result. For some bizarre reason, it's returned as CSV. So we use yet another Node module to parse the CSV. And that gives us back the response. We can see here smatterings of console.log statements throughout. They are what are rendered in the logs window. So if we go into the barcode service and have a look at its logs, so we can see the performing read, there's the response, and there's the JSON response that we're sending back. Again, it's the most recent one we did, the Big Bang Theory. So that, I mean, that 70 lines is the entire implementation basically for the interaction with Search UPC, both for listing recent and for looking up product details. Final quick thing I want to take a look at then is the image service. So we saw back in our Node.js API server that when we read a barcode, we get the response back, we delete out the stuff we don't want, but we then make a call to the stream service, giving it the URL that we got back from Search UPC and asking it to give us back a stream of data. In this case, we're saying we do want the base64 encoded because we want to just squirt that into the response that's going to go back to the client. So, image stream. Again, application.js mounts one root image into image.js. Mounts the root. Just some logging on the URL and whether we want base64 or not. And then this is, it's basically a single line implementation. We make a request for the URL provided. We pipe it to a base64 encoder and then pipe that straight back out. And that's one of the really kind of nice, one of the really powerful things about Node is the fact that streams are supported as a first-class citizen. So really doesn't matter how big a file you're dealing with, you can stream it through, re-encode it, do whatever you want to it basically, and stream it onward. So it's very easy to process very large files without having to load everything into memory. If we're not base64 encoding, we literally just make the request and pipe it straight out to the response. And then as we saw back here, when we get the response back, we just stick it into the object, the JSON object that's going to be returned, and return the whole thing. So, just to prove that this is not all smoke and mirrors, this is the bit that always doesn't work. Come on. I swear to God this was working less than an hour ago. Excellent. Okay. So we have the client app installed. We can again see the list of recent searches. But in this case, because the app is now running on device and has access to a camera, we can use the scan barcode button to actually, well, scan a barcode. So for everyone who's watching remotely. So there's one I checked earlier. There we go. And we search. Yeah, man. There we go. Voila, water. And we can see if we go back and refresh our logs, we'll be able to see the logs of those requests going through and the responses coming back through. So there we go, there's our still spring water, the link to the image URL, and so forth. That is pretty much all I wanted to cover, and we are bang on the top of the hour. So I'm going to throw it open again if there are any questions.
Any questions, anyone? I asked mine as I was going through. No?
No?
Okay, it's very interesting. Thanks, John. Thanks for giving us the talk. Yeah.